Today we're doing lesson 3.4 on graphing functions. So in this lesson we are going to graph a function when we're given a domain and a range. Sometimes we're going to be given a limited domain and range, and sometimes it will be just everything. So you'll just graph the function as is without a restriction on what x values and what y values you can use. So that is what we're going to be working out today. An example of this used in the real world, scientists can use a function to make conclusions about rising sea level. Sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continues, the function y equals 2.5x can describe how many millimeters y sea level will rise in the next x years. One way to understand functions, such as the one above, is to graph them. And you can graph a function by finding ordered pairs that satisfy the function. So we'll make tables to help identify ordered pairs that are in the function and then plot them on a graph. So we're going to go ahead and start by looking at example 1. So example 1 says graph the function for the given domain. Negative x plus 2y equals 6. And the domain, our x values are negative 4, negative 2, 0, and 2. So first, we want to isolate this y value. We want to get y equals something for our function. So we're going to go ahead and solve for y since you are given the domain or the x. So I have negative x plus 2y equals 6. I want to get the term with y by itself first. So I'm going to add x to both sides to make this a 0. So minus x plus x gives me 0, so I'm left with 2y. And then I have 6 plus x. And I want to get the value of just 1x, so I'm going to divide both sides by, get the value of 1y, so I'm going to divide both sides by 2. 2 divided by 2 is 1, so I'm left with y. And then I have 6 plus x over 2. And I could also rewrite this as y equals 6 over 2 plus x over 2 by splitting it into two fractions. 6 over 2 equals 3. And then I have x over 2, which I can leave as x over 2 if you want. You can rewrite it as 1/2 x. Okay? And in the book, they just rewrote the order. They wrote it as y equals 1/2 x plus 3. Both mean the same things. Okay? So you could leave your function like this, like this, like this, or like this. There's a couple different options here on how you can write it. So now that we have y isolated, we have our function. So we're going to substitute in negative 4, negative 2, 0, and 2 for our x, and then simplify to get the value of our y. So we're going to have 1/2 times negative 4 plus 3. So that'll give us negative 2 plus 3, which equals 1. For negative 2, we have 1/2 times negative 2 plus 3. Half of negative 2 is negative 1 plus 3 equals 2. And then for 0, 1/2 times 0 plus 3. 1/2 of 0 is 0 plus 3 gives us 3. And then 2, half of 2 plus 3. Half of 2 is 1. 1 plus 3 gives us 4. So then our ordered pairs would be negative 4, 1, negative 2, 2, 0, 3, 2, 4. And we plot those on our graph. So negative 4, you go left 4, up 1. Negative 2, 2, left 2, up 2. 0, 3, you're not going left or right at all. You're just going up 3. And then 2, 4, right 2, up 4. So that's what your graph would look like. There is a part B to this. We're going to look at another function this time. We have f of x equals the absolute value of x, and our domain is negative 2, negative 1, 0, 1, and 2. So we don't have to go and solve for y this time. We're already given it in function notation, so we can just start substituting in those values for x. So we're going to have the absolute value of negative 2, and that equals 2. So our ordered pair is negative 2, 2. Absolute value of negative 1 is 1, so our ordered pair is negative 1, 1. Absolute value of 0, 0, so 0, 0. Absolute value of 1, 1, so our ordered pair is 1, 1. And then the absolute value of 2 is 2. So our ordered pair is 2, 2. So to plot those, negative 2, 2, left 2, up 2, negative 1, 1, so left 1, up 1, 0, 0, that's your origin, so right here. 1, 1, right 1, up 1, and then 2, 2, right 2, up 2. Okay, so you fill out your table and then plot your ordered pairs. There are 2 check it out problems for you to try. So go ahead, pause the video, try these 2 on your own, and then resume when you're ready to check your answer. All right, so for this first one, we have negative 2 plus y equals 3. So we have to solve for y first. So I have negative 2x plus y equals 3. So I'm going to add 2x to both sides. So that gives me 0. So I have y by myself. And then I have 3 plus 2x. Okay, so I'm going to create a table. So I have my x and my y. My x values are negative 5, negative 3, 1, and 4. So I need to substitute in my x values into my equation here to get my y. So I'm going to have 3 plus 2 times negative 5. Okay, this 2 times negative 5 will give me negative 10, plus 3, negative 7. So my first ordered pair, I'll just list them down here so they're easy to see, is going to be negative 5, negative 7. Okay. My second one, I'm going to have 3 plus 2 times negative 3. 2 times negative 3 gives us negative 6, plus 3 is going to give us negative 3. So our second ordered pair is negative 3, negative 3. Then we're going to have 1 in for x, so 3 plus 2 times 1. 2 times 1 is 2, plus 3 is 5. So our next one is going to be 1, 5. Last one we have 4, so we're going to have 3 plus 2 times 4. 2 times 4 is 8, plus 3 is 11. So our last ordered pair is going to be 4, 11. So on my graph, I'm just going to scale by 1. So one block represents 1. So negative 5, negative 7. So left 1, 2, 3, 4, 5. Down 7. 1, 2, 3, 4, 5, 6, 7. So I plot it right there. Negative 3, 3. So left 1, 2, 3. Down 1, 2, 3. 1, 5. So right 1, up 1, 2, 3, 4, 5. And then 4, 11. So right 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. This one just goes off the graph a little bit because I only go up to 10. Okay? So that's what your graph for the first one will look like. Second one, our function is f of x equals x squared plus 2. So f of x equals x squared plus 2. So I'm going to list out my x values. So my x values are negative 3, negative 1, 0, 1, 3. And then I'm going to go find my y values, or my f of x. So, negative 3, I'm going to have negative 3 squared plus 2. Negative 3 times negative 3 gives me a positive 9, plus 2 gives me 11. And then I'm going to have negative 1 squared plus 2. Negative 1 times negative 1 gives me a positive 1, plus 2 gives me 3. And then I'm going to have 0 squared plus 2. 0 squared is 0, plus 2 is 2. And then I'm going to have 1 squared plus 2. 1 squared is 1, plus 2 gives us 3. 3 squared is 9, plus 2 gives us 11. So our ordered pairs are negative 3, 11, negative 1, 3, 0, 2, 1, 3, and 3, 11. So negative 3, 11, and that'll go off the graph. Negative 1, 3, 0, 2, 1, 3, and then a positive 3, 11. So that is what your graph would look like for part B. Okay. Now we're going to look at example 2. So here it says if the domain of a function is all real numbers, any number can be used as an input value. Okay. So the example we just looked at, we just had specific values that we put as our input. For functions that have infinite number of ordered pairs that can satisfy the function, you can just substitute in any number for your input. Okay. So this process will produce an infinite number of ordered pairs that satisfy the function. Therefore, arrowheads are drawn at both ends of a smooth line or curve to represent the infinite number of ordered pairs. If the domain is not given, assume that the domain is all real numbers. So those arrowheads will show you that on a graph, the function continues, it doesn't just stop. Okay, it keeps going. So graphing functions using a domain of all real numbers. Step 1, use the function to generate ordered pairs by choosing several values for x. 2, plot enough points to see a pattern for the graph. And then step 3, connect the points with a line or a smooth curve. So when I do these, I try to pick some negative numbers, 0, and then some positive numbers to substitute in for my function to get a good idea. So typically you want to start with at least like 5-ish input values to help you set up your graph. If you don't get a good idea of what your graph looks like and what the pattern is, pick some more x values to substitute in to extend your graph, and then hopefully you can get a better picture. Okay, so here, part A, it says graph each function. We have 2x plus 1 equals y. So here are some x values that were chosen, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So it's always easiest to pick whole numbers, no fractions or decimals unless your function involves some fractions and decimals that you could easily pair with another fraction or decimal to get rid of it. So here we have negative numbers, 0, and positive numbers. So like I said before, it's good to pick some negatives, zeros, and positives. So here we're going to substitute those in. So 2 times negative 3 plus 1 gives us negative 5. Negative 2 times 2 plus 1 gives us negative 3. 2 times negative 1 plus 1 gives us negative 1. 2 times 0 plus 1 gives us 1. 2 times 1 plus 1 gives us 3. 2 times 2 plus 1 gives us 5. 2 times 3 plus 1 gives us 7. So these are our ordered pairs. Negative 3, negative 5, negative 2, negative 3, negative 1, 0, 1, 1, 3, 2, 5, 3, 7. And then you would plot them on your graph and connect them. Draw arrows at the end to show that the function continues. So here the ordered pairs appear to form a straight line, and you would draw a line through all of them to connect them, and then like I said, draw arrows on the end to show that they continue. Okay. Now we're going to look at part B. We have a different function this time. We have y equals x squared. Okay. So again, pick some positive and negative numbers and 0 to substitute in. Here they did negative 3, negative 2, negative 1, 0, 1, 2. So we're just squaring them. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So these would be our ordered pairs. Okay, I'm going to graph it on this graph just so you can see it in a different scaling where I'll increase by 1. So we have negative 3, 9, -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. So that's what my graph would look like, okay, with the ones that I just plotted. If you don't really see a pattern, you can add some more x values to help you out. You kind of see an idea of what's going on. It's a curve, so you would connect your dots, okay, and then it's going to go up, and then you draw your arrows to show that it continues, okay. So the ordered pairs appear to form a almost U-shaped graph, so you draw a smooth curve through the points to show all the ordered pairs that satisfy the function. Draw arrowheads at the end of the curves, okay, to show that it continues, like I did. So if the graph is correct, any point on it will satisfy the function. You can check by choosing an ordered pair on the graph that was not on your table, such as 3, 9. So here we go right through 3, 9, so you can check that. Is 3 squared equal to 9? Yes, it is. So that would be a good way to check if your graph looks great. Okay? There are 2 check it out problems for you to do. A is f of x equals 3x minus 2, and then B is y equals the absolute value of x minus 1. So go ahead, pause the video, try these 2 on your own, and then resume the video when you are ready to check your answer. Okay, so for A, we have f of x equals 3x minus 2. Okay, here I'm going to set up a table, my x and y values, and I'm going to pick -2, -1, 0, 1, 2, and 3, and see if I get a good idea of what my graph looks like. So I'm going to start with -2, so 3 times -2 gives me -6, minus 2 gives me -8. -1, so 3 times -1 is -3, minus 2 gives me -5. 0, 3 times 0 is 0, minus 2, -2. 1, 3 times 1 is 3, minus 2, 1. 2, 3 times 2 is 6, minus 2 is 4. 3, 3 times 3 is 9, minus 2 is 7. So from here you can plot your ordered pairs. So -2, 8, so left 2, down 8. -1, 5, left 1, down 5. 0, 2, so 0 and down 2. 1, 1, so right 1, up 1. 2, 4, so right 2, up 4. And then 3, 7, right 3, up 7. So your graph would look something like this. So then from here, you could use a ruler to kind of connect your dots. Or if you're really good at drawing straight lines, you can just draw the straight line. And then you would draw arrows at the end to show that it continues. Okay, so that's what your graph should look like for A. B, I have y equals the absolute value of x minus 1. I'm going to set up a table again. This time my table is going to be a little bit longer just because my graph is pretty big. So I'm going to use -3, -2, -1, 0, 1, and 2, and see if that's enough points to get an idea of what's going on. And again, if you don't get a good idea, then add some more points to your table and plot them so you get a good picture of what's going on with your graph and with your function. So absolute value of x1 is 1. So -3 minus 1 is -4. Absolute value of that is positive 4. -2 minus 1 is -3. Absolute value of that is 3. -1 minus 1, -2. So absolute value of -2 is positive 2. 0 minus 1 is -1. The absolute value of -1 is 1. 1 minus 1 is 0. And the absolute value of 0 is just 0. Okay. And then 2 minus 1 is 1. The absolute value of that is 1. So I'm going to go ahead and plot these. So I have -3, 4, -2, positive 3, -1, positive 2, 0, 1, 1, 0, and then 2, 1. Now, I'm going to add a couple more points here. I'm going to add 2 more, 3 and 4, to see what that gets me on my graph. Just because we see it's kind of going that way, but I just want to double check that it's going to continue going up. So 3 minus 1 is 2. Absolute value of 2 is 2. So that's going to be 3, 2. 4 minus 1 is 4 minus 1 is 3. Absolute value of 3 is 3. So our point would be 4, 3. So right here. So our graph would look like this. Don't forget to draw your arrows. So it looks like kind of a V. All right. So now we're going to go ahead and look at example 3. Finding values using graphs. So sometimes you're going to be given a graph and you're going to be asked, okay, use this graph, make a prediction, or find the value of y when x equals blank. So here it says use a graph of the function f of x equals 1/3 x plus 2 to find the value of f of x when x equals 6. Check your answer. So on our graph, we're going to go find 6. So 6 is right here. And then we go over to find the y value. So when x is 6, y is 4. Okay? So you could check using substitution as well. Okay? So there is a check it out problem. It says use the graph above, which I just pasted here again, to find the value of x when f of x equals 3. So go ahead, pause the video and try this one on your own. Okay, so 3 is right here. So I'm going to go up here and then go on over to the side. And we're scaling, it looks like, by 2, 4, 6. So this would be 2, so that would be 3. So when f of x equals 3, our y value would equal 3. So y equals 3 here. So now we're going to look at example 4. Recall that in real-world situations, you may have to limit the domain to make answers reasonable. For example, quantities such as time, distance, and number of people can be represented using only non-negative values. When both the domain and range are limited to non-negative values, the function is graphed only in quadrant 1, because your x values and your y values are both positive in quadrant 1. So here the function y equals 2.5x describes how many millimeters sea level y rises in x years. Graph the function. Use the graph to estimate how many millimeters sea level will rise in 3.5 years. So first, understand the problem. The answer is a graph that can be used to find the value of y when x is 3.5. So important information here is the function is y equals 2.5x, and that describes how many millimeters sea level rises. So first, you should make a plan. Think about what values you should use to graph this function. Both the number of years sea level has risen and the distance sea level rises cannot be negative. So you would start with 0 and then use some positive numbers. So use only non-negative values for both the domain and range. And this function will only be graphed in quadrant 1. So now we're going to go ahead and start solving. So we choose several non-negative values to find the values of y. So we chose 0, 1, 2, 3, and 4. So we used our equation, y equals 2.5x, and substituted in 0. Got 0. Substituted in 1, 2.5, 2, 5, 3, 7.5, 4, 10. And then we got our ordered pairs. Then we would graph. And I set up a graph over here. This is the one that's in your book. So I scaled 2 blocks equaled 1 on the x and y axis. So 0, 0 would be right here. 1, 2.5 would be here. 2, 5 would be about here. 3, 7.5, and then 4, 10. Okay, so this is what my graph would look like. And I only draw an arrow at the top up here because that's going to keep on extending. This direction it does not extend because remember we're only talking positive values here. Time and rise in sea level will stay positive in this example. So now we're going to use the graph to estimate the y value when x is 3.5. So 3.5 is right here. So we're going to go up to our graph. Okay, and then we're going to go over. So 3.5, we're going to go over here. So it looks like it's about 8.5. So as the number of years increases, sea level also increases. So the graph is reasonable when x is between 3 and 4, y is between 7.5 and 10. Since 3.5 is in between 3 and 4, it is reasonable to estimate y to be 8.75 when x is 3.5. Or you could use about 8.5 when you're looking at your graph. So this is an estimate, so it's approximate guess. It doesn't have to be perfect, okay, as long as it is reasonable for the situation, okay? There's a check it out problem for you to try. It says the fastest recorded Hawaiian lava flow moved at an average speed of 6 miles per hour. The function y equals 6x describes the distance y the lava moved on average in x hours. Graph the function. Use the graph to estimate how many miles the lava moved after 5.5 hours. So go ahead, take a moment, pause the video, and try this one on your own. So here, we're going to talk positive values for time and distance. So I'm going to set up a table. So x, y, and I'm going to use 0, 2, 4, 6, 8, and 10 for my x values, okay? And my equation is y equals 6x. So 6 times 0, 0. 6 times 2, 12. 6 times 4, 24. 6 times 6, 36. 6 times 8, 48. And 6 times 10, 60. From here, I could just graph these. So 0, 0, 2, 12, 4, 24, 6, 36, 8, 48, and then 10, 60. So our graph would look like this. An arrow only up top, not at the bottom. So here, I need to estimate 5.5 hours. So 5.5 hours would be about here on our graph. Okay, and then I would go over to my y-axis. And that would be about right in here. So I would say about 33. Yeah, so in between 30 and 36, so about 33 miles would be a good estimate there.